Good morning and welcome back everyone to our workshop series. Um, Today our workshop is a workshop number 3, Landscape BIM Workflow with the Building Disciplines. This is the workshop in the module 2, Landscape Digital Workflows. My name is Yuben, or you can call me Ben. I'm the BIM list for the landscape team in Abu Dhabi office. So our workshop today will be divided into the 3 parts. We try to understand uh, why, where, and how the coordinations of landscape with the building. First part, we're going to try to understand why the building need to have a coordination with the landscape. And first of all, it will be try to understand the interface. What is the interface between the building and the landscape? Why this is matter? The information and geometries. And the last is the BIM approach with BIM at the information exchange platform. So in general, our landscape design workflow will be like first we receive the building informations, and from that we start with the design. Uh, with help of many tools, we will try to finalize the design and deliver the our landscape products. Before starting with the tool support for the interface coordination like Revit links, Navisworks, Revito, class detections, we must review back to understand the building and landscape interface and what it is. We can have the general answer that any location where the landscape design depend on the information from other discipline is the building landscape interface. So why the coordinations matter? Because when the landscape begins, many decisions already exist. We will have when we're starting, we already have the building engines, basement extents, bottom slab, structure beam, utility corridor, drainage system. So we already have those information exist, and we need to have a well coordinate. And the landscape have some uh, unique characters, like we have the integrated layer where the landscape is not isolated scope. It needs to be integrated layer with the building environment in the form of essential link between the human experience and the structure form. The second is when we look on the vertical, especially when we're working with the building. In the vertical, we have landscape have a quite complexity where landscape often sits on top of basement or podium or terrace and roof. Every square meter of the subscape is supported by structure or mechanical system. Lastly, we have landscape have direct adjacency, where we landscape object on way thus connecting with other objects from landscape, from architect, from structure without gap. We touching directly, and like engines, like facades or service zones, we need to have a very precise alignment. Any mismatch of level or surfaces lead to the costly site modifications. And without the coordinates, project may face critical failures during the construction and long-term maintenance. Uh, a couple error we could highlight here, like the structural conflicts, the insufficient depth, drainage failure, um, the utility classes and level mismatch. And with last couple workshops, we have got the idea that BIM workflow actually can enhance a lot on the design workflows, a design process. And in this case, in this coordinations case, and the BIM workflow also provide tools that can help to enhance to make the design coordination more efficiency. That is the informations or the workflow of information exchange and the geometry, the 3D geometry for coordinations. But first of all, we need to mention that mm, the issues of coordinations is more about the information issue. Many people think about coordination meaning like 3D model, classes, Navis work, or federated model, but the coordination issue is just about lacking information for coordinations. Many coordination issues are discovered through the information exchange rather than the geometry class. Because we know that um, many informations already be exist before the landscape start their design. For example, in the case of uh, the soil depth, the landscape architects may require some um, depth for the landscape um, planter or softscape, but turn out the information we receive of the structure um, depth, available structure depth. The information from structure at that moment, from very early design state, even without any 3D model, already can expose the problem of the coordinations between the requirement from the soil depth in landscape and the available space from the structures. But many other information also can be discovered through the information exchange. And from every discipline, they have a lot of information and they're gonna sharing to the BIM environment platform. For example, architect gonna share their information about the building footprint, the entrance, the levels, finishing floor levels, the access roost level, and structure sharing their slab level, structure zone, loss limitations, and maybe can sharing about the information of utility corridor, drainage system, electrical infrastructure system, and all this information will be exchanged to the BIM platform. With this informations, the architect can starting their design, testing the feasibilities, and also sharing back the information to receive the feedback from architect or other discipline. And this workflow keep uh, repeatedly on the information exchange workflow keep be repeatedly on the BIM platform, on the 3D digital coordination platform. So on of the stakeholder, on of the designer can be aware about the latest information and can also physically seeing the information of 3D model. So in general, we can say the landscape gonna working with a lot of information from different disciplines, multiple disciplines, and also reverse back to those disciplines about the landscape design informations to can help the well coordinate. And this process of exchange information can happen many times, repeatedly, many times. And the exchange information between different disciplines will be happen on a coordinate digital environment. This meaning like 3D model exchange on the platform, um, like the cloud platform ACC or BIM 360 that we have used for many projects before. The next one we are going to will be the second part where we'll have the coordination happened. Uh, we will review some error like hardscape interface, softscape interface, some major error about level and drainage coordinations. We also get to understand that the coordination is not happen in one times. It's gonna evolve as the project matures. So, as mentioned earlier, we need first understand that the design um, the coordination interface is happen based on the design phase because the coordinations is not happen on at once. Coordinations is evolves as the project matures, like on the concept design. We just need to focus on some specific areas, such as like the building engines, the landscape concept idea, like the arrangements of blending areas of the circulations, and several different things on the landscape concept. The main circulations, yes, the view corridors, the major level strategies. But moving to the schematic design, our focus now is about the gradings, the tree location, retaining walls, the drainage concept, and the design development in this area based on our deliverable design. We need to focus on paving pattern, the thresholds detail, structure openings, planter build up, equations rules, lighting coordinations, and the last one is about the construction document. We are focusing on the setting out of every landscape objects, dimensions, precise dimensions, precise level, um, construction document details, utility corridor coordinations. Sorry, class free model or documentations. Uh, we can also segregate them based on the discipline. For example, we can see the building entrance and threshold is on under the architect discipline, coordination with architect disciplines, plaza interface, retail frontage, lobby to the side transitions, the transition from the facade, to the architect to the side of uh, outdoor landscape. Uh, and structure other side, we are coordinate with the slab, with the loadings objects, water features, structure support, three big, three depth, three big, three soil depth, and three big reinforcement, MEP system and facade system. Now look closely into a hardscape interface. When we isolate the hardscape interface, we're gonna see um, the hardscape from landscape gonna be coordinate with like paving finishings, paving buttons, engines, thresholds, and material of transitions. So at that moment, the beam tool we can use to help coordinate on those level could be the model reviews with software like Revito, Navisworks. In Revit, in the modeling tool, we can directly checking with some feature like making a sections of the transistence error. For example, like the to checking on the entrance thresholds of material transitions, we can use the Revit to make the sections at the transition error where we see the level of the entrance of the threshold transition from the outside to inside. We also can making some blend view to see the material or the paving buttons transition from the outside to inside to ensure the mapping or alignment between the architect and landscape object in terms of material transition and the level transitions. We also can use a couple other tools like Revit and Navisworks to can do the overlay, the architect and structure, uh, the live model from architect and live model from landscape to can see and checking the coordinates between two models. Some other tool on Revit modeling software to can help quickly identify the challenge of coordinations on the level, like spot elevations on the Revit to can checking the level transition. That is the one major issue between the architect and the landscape. For the structure, most of the time we're working with the slab edge with the Mosman joint, expansion joints conflicts, and the structure opening. With help of the beam models and the tools, we can quickly using some features of the model tools like cut, like section cut in Revit, Navisworks, or any kind of beam tools. You can checking the interface between the structures and the landscape overlay between the structure and landscape model. Uh, this help a lot when we're checking the clearance between the structure and the landscape objects. For MEP, the major object we do coordinate with hardscape will be uh, the train strength, the manhole, the special and manhole with paving uh, in landscape, the pavings and the grave on landscape to make sure like they are alive. Uh, so similarly, we can use the coordination model like Revito and Navisworks to checking the combined model between the MEP and landscape. We see the to checking and identify the mismatch. We also can check the level coordinates between the surface from landscape with the object on MEP, like the drainage, the trains, and the manhole with the level, the surface level from um, landscape. We gonna go through some example case later. We demonstrate on the real projects. Uh, this is just a summary, some of the major object we're gonna working with um, discipline from hardscape. Similarly, we also have this kind of identify what is the object, what is the errors and the object does the softscape in we need to coordinate with other discipline like the architect, structure, and MEP. Also coming up with some methods how BIM tools or BIM workflows can help to identify and resolve this problem. With hardscape, with softscape, we have to checking about the blender as uh, facade clearance visibility for coordinate with the architectures. We're gonna using the 3D visual clearance zones, checking by ferreted model by Navisworks and Revito. We also can do some solar and shadow study integrations on Revit. We can use the software like Revit to do the study about solar and shadow study. Um, with structure for softscape, probably we have to work with the solid diff, where we mentioned quite a lot about how to coordinate the structure available space with the requirement from Blender of the softscape. In that specific one, we can use the software like Revit to checking or Navisworks to check the class of the space, the clearance space for coordinations, and so on. We have other tools mentioned there for the MEP in terms of irrigations and drainage, lightings, tree root conflicts. In terms of the level and drainage coordinations, um, s- this kind of similarly. This is just a table list down on the major areas need require to connect between the different disciplines. We're gonna review this later with more specific case of example case. Building edge or the facades. This is the way landscape literally met the building. We also have different types of object from the architects, structure, MEP that's require the coordinations, and also here have some proposal tuned on the methods how we get over this coordinations issue error. Summary, summary on of the point we have going through. We have a one kinds of class metrics where we pointing out every landscape package and the requirement coordinate with its disciplines. So I would like to continue with the last part of our workshop today. Is uh, how we doing the coordinations between landscape and other disciplines. In this part, we have two uh, items to reviewing. One will be the design workflow with the BIM tools, and the second is some example case. Um, a typical building and landscape workflow for design in general that will going to 5 step. First of all, we're gonna receive the design inputs. That could be information about the building entrance, structure slab, and MEP, uh, like MEP utilities, and different kinds of system. So all of this information gonna be sharing on the one platform like ACC. The one cloud platform allow everyone can able to access and receive the latest informations. Any updates information also can be can be noticed, can be highlight to on the people in the loop. Uh, the information we receive maybe have variable formats from Revit model to AutoCAD and Civil 3D. And sometimes we also have to work with some document paperwork. Based on that, we gonna developing our design like planting zones, hardscape, plaza, and water features. Mainly, we're gonna work with Revit. Sometimes we also work with Civil 3D and AutoCAD also. And next step, we have to initiate the review. The review could be based on the 3D model or maybe just only the 2D case. We already can do some coordinations like the level verifies or soil depth checking. Some information require the 3D coordination. We need to use the tool like Navisworks or Revisto. The fourth step, that will be solving the issue where we require the communicates between different disciplines. This is about the human interactions. Uh, some of activity we have to do, and that's time we like from the landscape. Most of time, the landscape have to adjust their design to adopt with the system or adopt with the structure frame, the shape of building from architectures. So we have to do some adjustment, like adjust the depth, or making new solution on design, uh, rearrange the level. Sometimes we can also request the other team, like the MEP team, to reroute the utility system. So the successful beam is not just about the subway; it's about the quality of communication between discipline. And after we finalize on the step on the solution, we're gonna finalize the design with the um, um, ultimately the LD 300 for modeling and some detailed spec and drawing package. Uh, Before we moving forward, I would like to take a couple slides to remind about the BIM workflow in general. So in general, we in the BIM work process, we're gonna have a 6 step from the master planning to IFC. So every state we do have to deliver some level of informations and the level of detail level development information from LD 100 up to LD 300 or 400. Um, every state we have a different focus and requirement. Uh, our strategies is uh, no matter what is the concept tool we are using, we still must fit into the Revit that they cannot be replaced. Um, Even we are working on Civil 3D, but Civil 3D handover become a foundation of Revit LD 100. Revit is the single beam authoring platform for concept to IFC. Um, from the schematic design onward, the Revit is mandatory for beam authoring tool for all landscape projects. Civil 3D can act like the fitting topography data into Revit, um, but eventually, on the final product, we have to hand over by Revit format and Revit delivery. Um, so a couple more slides just for explaining about the how the modeling and the process we developing the model for landscape. Um, Before we go into the coordination, we'd like to remind about this workflow a little bit more. So we're starting with the LD 100 when we receive the information from different disciplines. For example, the case of, for example, in this case, when we receive the MEP utility, drainage, irrigations, and then we starting overlay on of this information and developing our model. And right after we have the base model at the LD 100s, we already can able to generate the drawings, productions, sheet productions, and start with the design integrations for coordination purpose. And from that state, we're moving up to the LD 300 for design development with more detail and full coordinate with the drainage and MEP. On the component model with the geometry and parameters, LD 400 for construction document on the fabrication level detail, and LD 500 for Hanover and IFC. This time model have been included on of the Kobe data for manufacturing for facility management. Um, so IFC is a compliant for IFC compliant is a requirement with no alternative tool can deliver like Rhino, Civil 3D alone or AutoCAD that cannot fully satisfy. We have to go with Revit only. Um, to explain a bit more about the coordination work, I have to recall again about the BIM team hierarchy to explaining more about who doing work what and how does work relate to the coordination. So in general, any kind of project, our hierarchy will be have this much level with a 4 level for the BIM managers. That will be the project BIM managers uh, who managing on kinds of standards requirement from client and arranging the space for all discipline can come and starting their BIM productions. Um, Lower level we have the BIM coordinator, project BIM coordinator who managing the technical stuff on beams for across different discipline, and every discipline have their own beam coordinators. Like landscape, we have a beam coordinator here to supporting on the technical work for landscape specifically. And behind us, the representative, we have the landscape technical list who not much involved on the beam work, but more about the landscape technical. design technicals are associated of landscape architectures. Simultaneously, we have the group of production team with Revit modelers or BIM technicians. The BIM managers just simply the person who managing on the requirement from the client, from the EIR, the requirement from client employer, and translate that into a BIM execution plan, a 1 BEP, try to answer on the question from the client. And with us, we have the idea what is the BIM deliverable, the MIDP, on the list of items that we have to deliver. Project being project coordinator, just like explained earlier, that will be the person who execute, who set up the whole workspace, and who actually start creating the cloud detection, issue management, or we can say the hub to recording on the class, who also set up the weekly BIM coordination call that allow on of the stakeholder can be participant and um, raising on of the issue from uh, design, try to find or solve the problem. And from landscape BIM coordinator, this ideally should be the senior landscape architects. This is the most critical role for the landscape BIM team, will be split equally between BIM management and production management, meaning 50% on BIM management about the BEP compliant cloud detection issue tracker, weekly BIM coordination calls with other BIM discipline coordinator, and 50% on production management, who daily catch up with the sub-consultant, with production teams, uh, yeah, and managing the allocations on BIM technical knowledge and landscape design experience. We also require the involved from the technical leads who own design intents and work hand in hand with the BIM coordinators. So landscape technical leads is typical is the associate or the senior landscape architect is who is responsible for design directions and technical qualities. But this person the involving level is more about like working closely with the BIM coordinator uh, for execute the strategy. Who also review and approval for the BIM output, um, and rate a solution when we facing the challenge. Um, Lastly, we have the BIM modelers or the BIM Revit modeler or the BIM technicians who actually hand on productions, full responsible of the building and maintenance the Revit landscape model, who can be in-house or sub-consultant. Um, the person who mainly develop the hardscape, softscape, and furniture object in the model, who also managing the system of standard system uh, components like Revit families, uh, and dealing with the packet delivery schedule. So that is the everything of the theories for understanding about the interface between the landscape and the buildings, some idea about the workflows, how do we developing the model and starting for the coordinations. Also have some slide mention about the tool or the solutions of the software for helping address the coordination issues. Yeah, using the tool BIM tool. Now we're going to learning in some specific case, and in this time we also try to go through a couple tool BIM tool software to help uh, address or uh, try to review the model for coordination purpose. Uh, Obviously, the we will not we do not have enough time to can learning about the tool, but I will try to introduce some basic uh, uh, basic use of the tool that's easy for everyone can implement or try to use on your daily work. So this image is try to highlight us we going through four area of the coordinations with different discipline. The first one, we will review the very typical one very common issues of hardscape. It's about the engine threshold. The typical issue is we usually have the difference of the level mismatch. Uh, the tactile paving terminations incorrect. The paving model doesn't align with the engine axis. So the result could be like we have the water flow into the lobby or into the buildings, and some intended step created. And this we I would like to introduce about the tool Revit, because this tool is very easy to identify these issues, and we also can correct that directly on the Revit, the modeling tools. Mm. So So first of all, before we go into the specific case, I would like to introduce the BIM 360 or ACC. The new name is Autodesk Forma. Uh, I believe some of us already have experience working with this platform, but also would like to take us some minutes to introduce again. So here I have the one projects of the building and landscape. For example, of our case, coordination case, this is the one project, and here the structure of the folder on that platform, the cloud platform, where we store it on the model and even include our work in progress model of landscape. So we usually working under the subfolder name 930 beam in, under the WIBs, and we have a one landscape folder, meaning our own workspace where we can keep on of our um, WIB files. And beside that, we have one folder named Share folder where other disciplines, other team who sharing their model, official model for design coordination purpose. So you can find um, major discipline team is here like architectures. When you click on that, you also can see their model. In here, they decided to sharing at the Revit format only, but some other project we may see other kinds of format like Civil 3D, IFC, or even Navis work. Um, and other team like structure, waste utilities, um, mechanical, plumbings, electrical. So most of the project we have this kind of similar structure folder where on the discipline we're sharing their files under the share folder, and our own WIB file will be under WIB folder and the name of our team structure. So here is for the mm, on the folder inside our WIB, we can segregate based on the our niche. Could be the folder for the CAD format, um, family Revit standard system, Revit standard component, and other kinds of format if we need. And here you can see that a couple model is there. It depends on the uh, naming convention of every project, so the file name can be different, but here you can find and easy to understand what is this inside here by the descriptions. For example, in this project we find us um, don't be bothered by this file is different in this project is a different meaning, so it's not really have the name here. um, but I think I correct the name later. But the major file we have here, the three file in here, where we have the six files, uh, and the second file is about the model for the level of site ground floor. Um, the third model is about the couple level like first, second, and third floor. model. So sometimes the model will be segregated based on the level. This is just a technique to reduce the file size and the complexity of the model. But you can understand the two major model we have in every project is the one sheet file would contain the sheet for sheet production and the one 3D model file which helping modeling and model management. So this is will be the location where we need to open. One thing about the ACC and the Autodesk format does, in case you're not sure what you're looking for, you can just click on the file and the web browser will present for you the content inside this model. For example, if I click here, the web browser gonna processing and showing me what is the contents inside that model is. So here we can see this is the landscape of the site level or ground level. Uh, Basically, we can find on of the planters visible, hardscape and softscape is visible too. And similarly, we can see for the another 3D model. Of course, in the sys file, they be empty because it's just a shake file. So that is the introduction about the workspace, the ACC workspace or the Autodesk format workspace, where all the discipline will come and working and sharing the file here. Our own model also be captured in here. Other kinds of information like project BIM management, BEP, you also can find it here. On the standard and system about the BIM requirement is here, captured on the ACC too. Now go back to the Revit model. In Revit model, if this is the first time you seeing Revit model, then I would like to introduce you the interface. So upon here, the report, you can find on of the modeling tools and the view management tool also here. On the panel of the left side, you can see the property panel which lists down the property. If you do not select any object, then this property is for the view. And if you select any object, the property gonna be changed based on the object you are selecting. On the right side, you see the project browser. Basically, this is the structure of the view and sheets inside the model. On the 2D view and 3D view, even sheet also be captured here. Um, to navigate the model, you can use the scroll button, just holding the scroll button of your mouse to pan up and down or left and right. You can use the scroll button to scroll in and out for zoom in and zoom out. Yes, so that is a couple of things that help you to get familiar with the Revit software. Now we go back to the case of hardscape about the level coordinate. For example, here I make the one example where we have the hardscape error um, intersect with the buildings of landscape of the architectures. Here we have some object of the hardscape here along to the external wall. And one thing we just find out that by using the level spot or spot elevations in Revit, we can easily identify that the level here right now seem have a problem when the level from outside is seem higher than the level inside. To do that, we simply just using the tool named spot elevations. We can find that on the tab annotations, and here we find the spot elevation. This can help us to measure the level of our objects. And here I will measure the object inside, and quickly we identify it seem have the problem when the floor inside, which is come from the uh, would this come from the the architect model we have named AR here seem lower than the our um, hardscape of landscape model. It's about 50 mm higher. So obviously this is seem a mistake. This could be the missing finishing level from the architect, or maybe just issue come from the uh, the landscape model. So we identify this, and the next step we have to do is we raise the concern to the both team, landscape and architects, to can review and agree which action, which side need to make the action. This is the one way we can address the level coordinates between the hardscape and the architect's model. We also can do the similar way with another tool, which ACOM using a lot, and I will also would like to introduce here. This is that is Revito. So when you first open Revito model, the interface of that software will look like this, where we have the similar model that I'm using for Revit, and uh, from Revit they have been published into the one software, one platform called Revito. So where we can also review the same um, location that we're checking, that is in the main entrance of the VIP lobby. So I also would like to introduce a little bit about user interface of this software for you can easy to use and reviewing the BIM model. So with this one, we also using the mouse with the scroll button. We can zoom in, zoom out the same way how Revit doing, but this model is working mainly on 3D. Last time we working Revit on 2D plan view. We also can work with 3D, but Revit is not so much powerful for reviewing model. Mainly we're working with 2D view. Working with 3D view, I suggest we can use the Revito. Um, so in Revito, you can see the performance quite impressive when we can zoom in and zoom out very quickly, navigate the view very easily. You can navigate the angle of the camera by holding the left mouse button, and in the right mouse button it's just holding the one position and change the angle. uh, Scroll up and down to zoom in and zoom out. And here, I would like to introduce the very powerful tool that we're using very often, named section. The one have a scissor symbol on top. When you click on that, it's showing the one symbol to make a sections. In here, when you're holding by the mouse, left mouse, and you move it near to the surface, any surface, object surface, then immediately they create for you 3D sections. And here we can make the kind of plan view on 3D 3D model. So again, here we're gonna checking the level. We have checked on the 2D plan view, floor plan view of Revit to double check. After making a section, we can close this. And here we'd like to introduce another tool named ruler, basically the measure tool, where we can check different um, kinds of measures, like the laser ranger, uh, the point to point to measure the distance, and also we have the minimal distance between two objects. This will be snap between two objects. The one we are using in this case will be the elevation measure tool. So here, when we measure, we can see now the level is changing. Um, but the level in the architect is still the same, will be 450s, and this is the level from landscape. So last time we see in landscape is different because that is the old model, and this is the new model after we correct the level. So the level now have been dropped down into the correct level and showing the right slope, which showing the slope. The highest point is from the edge of the building and drop down with the um, very slightly slope to have the slope for the water coming outside. So by this case, we see the issue have been addressed and then corrected. So with this, I have introduced a tool that can help every designer quickly have viewing the one of the very common issue, that is the level alignment between the hardscape and architectures. Um, the second case we can review thus will be the site furniture's coordinations, uh, very common issues. The one I taking for make example is the manholes, the cover manhole, the very common issues in many projects. Um, this case, we're using the model on Revisto, the early one to can review quickly. So in the Revisto, when you zoom around the model, you can find any kinds of object, the priority object that we are checking. For example, if we're going from the outdoor to inside, we find some object, maybe just by visual check, we maybe can find quickly some of the overlapping objects. In this case, I can find that the polar, when you select the object and hold this for a couple seconds, the information of object will be showing at the one dialog. So here we can see this is the outside outdoor stone bola from the landscape, and underground, the on the surface of the hardscape uh, of the paving, we can see this is the object from um, utility manholes, the side cable containment manholes. For more information, you can click on the symbol property. In here, they will showing more information about what it is objects, who is the last uh, modify the object or sharing the objects. Uh, the information like which discipline object come from also can find here. And go back to the last tool we're using, the sections. If we're making a section here, we can easy to find us our object, landscape object. We do have the foundations on the below object, and this foundation is right now is clashing with the manhole cover and the manhole structure underground. So this it can be uh, identified quite easily. This is the easy way to tracking, but we also have another powerful tool that's called the cloud detections in here. In Revito, we have the class automation, but in Navisworks, we do have a similar tool named cloud detections. In limit of time for this section, I will not able to showing the whole process. How do we using the tool cloud automations or cloud detection on Navisworks, but just want to highlight with you that beside to manually coordinate or checking the class, we also have many automation tools can help us easy to do the cloud detection in the very automation way. But this is the one case that we can easy to find out by just by reviewing on the model. Any change uh, from different discipline, this federated model, this combined model will always reflect it, and we can find the latest design. And right now, this is the latest design, and we find it seem have an issue. So I can also showing you one more step. If we find the issue, what is the next step we do? So usually with the Navis work, we have to export the cloud detection reports and arrange the coordination. But with the new tool, new powerful tool like Revito, we actually can take note that in specific case here is called create the issue. We can make the new issue and place this there at the class issue, and we can name the pupil that we believe need to be involved, need to help to um, exist or resolve helping to resolve this issue. For example, I assign one of my colleagues is X um, with giving um, the the descriptions about what the issue is, uh, the priority, the deadline, and more information about what discipline is belong to. Like I can assign that into um, the m- this is a cable mental, so maybe that's belong to the I'm not sure about the discipline who owning this object. So for this moment, I will just play that at the landscape object. Maybe the landscape need to be adjusted. And that's it. Now the on class will be recording in the issue tracker here. And anytime we can arrange the meetings, the call with on the person who relate to this class to come and have the quick meeting or quick call to define and find the solutions. This is one more case on the class issue. Um, the next one is about the case of building X coordinations, or we can consider the object relate to the facades or the external envelope of the buildings. Um, For example, I will take the 1K of the camera and the planter, which may block the camera visibilities when the trees have been grown into the mature trees. After years of growing, they become reach to the height can be blocking the camera operations. So we go back to the 3D model, the last 3D model. Again, we can also review the 3D model just by navigate and uh, and reviewing directly with the 3D model. We try to find on the surface the envelope surface of the building and see like any object from the landscape may impact to the facades or the building envelope. Some of the surface of this facade is related to ventilations and security uh, camera system. That will be very critical. That we should not impact our design should not be impact to their operations. Um, for example, in this case, I have found that right uh, into the engine gate of the parking areas in front of the entrance. We have the two tree um, very close. At the entrance of the parking area, we have the two big mature trees uh, which cover the a seam blocking the camera in here. So here we found the two small camera in front of the entrance, and these two big tree may blocking, not able to to have a visibility range for the camera for operations. So this two tree possibly we have to shift it a little bit to can have a clear visibility for the camera operations. Uh, yeah. So here I also can do one thing that I can move the object, the tree, a little bit to the left side to can have more space for the camera to can have a good visibility. Seems like this. We can also moving that a little bit further to can have a better space for this tree. This camera to can these two camera can have a better error visibility error. So this is a couple idea that we can use the beam model, the freighted beam model to coordinate on 3D. We also have the tool like class automation to checking the clearance for the camera operations and other kinds of horse class between the two objects. Like the last object is a manhole and the polar, the stone polar. But I would like to introduce for the easy tool first that we can navigate the 3D model, take a look closely with the object, the major object would relate to the major state, delivery state we are working. For example, this could be consider the checking between the camera and the planter here would consider a very detailed level of coordinations like uh, development design stage where we have time to can look very close into our object and coordinate with other discipline object. So the last case study, I would like to showing one of the very interesting case. That is about the softscape in and the build and the structure engine the structure. Um, so this is a very interesting project. One of the biggest project we have in AECOM. I think you already aware about is by looking the image on the right side. That is the MooCap projects from KSA. In this MooCap, I taking the one case that we identify the challenge of the design in concept design. This is the planter coordinate, the planter soil diff coordinate with the structure slab. So I would like to sharing the model, Revito model, the federated model of this project. So in here, we can see this is a very giant big model, a very complicated and giant big model. Um, the model is still just stop at the LD 200, and it will not have enough information to fully doing the class detections, but we can just doing the checking of coordination quickly on some specific case that we mentioned early. For example, I want to check the soil depth requirement for this planter because right now the planter have placing quite up randomly for concept purpose, but I have a doubt about the feasibilities of playing these trees on this kinds of in this area like the terrace and the roof. So by making the quick sections, I can easily identify how much depth available right now in the model that the tree is blazing. So I can see just by relatively measures by checking on the visit model, I can see it's quite a thing. The soil it's quite a things, and I can do a measure to can checking how much depth of this object is. With this, we have to measure quite closely to can snap in the right place. So right now, from the bottom of this soil to the top surface, the maximum of this area seem just only 800. This is the like the top one of the soil, and this seem not sufficient for playing the tree here. When the tree this mud high require about 1.2 to 1.5 meter of soil depth. And right below that, we only have the slab thickness, and it seems the solution to play the planter here is need to be revised. Uh, and that's help our design from placing the tree randomly without concern about the technical design technical perspective. We have to come up with some idea of solutions, like instead of playing trees on uh, the mount the mountings soil mountings earth mounting, we have to play them into a proper um, planter, the razor planter. And the razor planter have to be considered the structure below, which may or may not have the lotting um, structure lotting capabilities. This we need to have a coordinate between the structure and the landscape to can finalize what is the final design solution for planter for the this planter. So some of the practice would like to mention in my workshop today is first, we should coordinate the level first because the level is the most expensive problem. Verify the shape coordinates and the finishing floor level weekly. We better to checking this level weekly. Coordinate the soil depth early, so no matter the design state could be the concept design state, but we better to consider the soil depth of the planter of the softscape. A special are the critical for the plumbing, podium and the terrace. Um, we also have to have well coordinates with the structure in terms of the soil volume. Uh, and the third is using the simple geometry first, so we don't really need to work like over detail for the trees or the furniture before we doing the primary coordinates. We can using the very simple symbol even 3D model in very basics geometry. But first we have to optimize for the geometry or the model should be optimized for the coordination purpose, not for the graphics. After we doing the coordination, well coordination, we can moving forward to the graphics and presentation. Uh, we better to have an interface review every like weeklies every time, one specific days on the week, focusing on the major error like the entrance, the terrace, the service error, where the discipline physically touch the model for decisions. So every decision should be based on the model, based on the 3D. Any design chain, any design solution, we should consider when we're working directly with the 3D model. And that's it. My section is stopped now. I thank you for uh, attending, and if you have any questions or if you find interesting with any tool want to discover more, please feel free to reach out to me. And I will also giving the one favorited model for you to testing and try to working. That will be the Navis work model, which also a very interesting tool to using for model review and model coordinations. Thank you, and I appreciate that.